All right, so let me get Keynote open here. Oh, so this is what you have to look forward to in the 450 class. We're starting to implement BitTorrent. We're writing our own BitTorrent server client. All right, so we talked about a couple of design patterns. Just a reminder, design pattern is this concept. It's not an implementation. It's the concept of, there's kind of some good ways of doing certain things. So a design pattern says, a proposed good solution to a common problem. We've looked at MVC. We're experiencing MVC here through Unity, where, we can do some stuff over here, which then allows us to access it from the code side. We can do stuff on the code side, which then allows us to access it over here, like we see in our player object, where we have like a speed related to our player script. I have a couple of new things in here so ignore those for right now. But we can make those two things talk to each other, even though they're living in two separate spaces. That's the concept of MVC, but MVC does not dictate how they need to accomplish that. Just that it would be a good idea to have that mechanism in place. Or Singleton says, it's a good idea to put something in this global scope, something that's up here that a whole bunch of things need to have access to kind of conveniently access those things. So we're going to look at an example of that today. I'll also show you an example of that send message thing I was trying to do yesterday. I think I had either a misremembering or probably a misremembering, but a understanding of how that was meant to work. But I got it figured out now. It's fine. Doesn't quite solve the problem I wanted to solve, but actually solves a different problem. Okay, so let me kind of I'm gonna actually draw a picture here real quick just to give you some context for I did a comment thing. I want sheet. For no good reason, I typically call my Singletons Core. I don't remember when that started, but that's what I call it. Kind of like a core container where everything lives. Maybe a word of warning: don't just make everything in your entire program global, because then all of a sudden you got 4,000 variables. I mean, if you only need 2 objects to deal with something, maybe just pass it between those 2 objects. But if you have 3 or 4 or 5 or 20 parts of your program that all need access to maybe the current logged in user, something like that, maybe that makes sense to store it once and they all can just grab it. So when you get to a certain screen in your app, the top of it says, welcome, Mike. And they didn't have to do this, huge lookup to find out who's currently logged in. You just had the value up there somewhere. Also, if you have kind of global information that falls into different categories, you might choose to have different singletons for those. Maybe you have a singleton for, hey, network information, player information, room information, stuff like that. These would be just different files, and you're going to see singletons aren't really that difficult. I'm not really solving a real problem here. I'm just bringing in a couple of our objects that we're used to dealing with just to kind of play a game here. So as we get further into this and we want to make our game come to life, and we started seeing this when we were doing our multi-threading with our MUD, we have some stuff that might need to be governed by a some sort of global thing. So for instance, we have, let's say you have a current enemy on the map, and you have a current player, and you have a room. And even though this enemy might be inside this room and this player might be inside this room, they might not necessarily have direct access to the room or other information that's going on, or maybe abilities where this guy here, he knows about all the rooms in the map, perhaps. So we have our map object that maybe holds a collection of rooms. So maybe we call that guy Core. He holds all the rooms in the entire map. So maybe this enemy has the ability to teleport to a different room or something like that. Well, he needs to have that ability somehow. He only knows about the little world that's right around him. He doesn't know about some room down in a different part of the dungeon. All right. So perhaps we have a function called teleport random or something like that. That takes an inhabitant as a parameter. And because we've said that this core object holds all the rooms, so as the rooms are being built, we just add them to this singleton. This is our singleton in our example here. So now what we can do is the enemy, he always has access to this singleton. And the reason for that is all of the things, or a high majority of the things in here, are going to be static. So the singleton is going to be filled up with a whole bunch of static things for the most part. So now the enemy can just say core dot teleport random, pass himself in, and this guy who knows about the entire map can now pluck him out of the room he's currently in and place him into another room that he knows about somewhere on the map. Let's just say. Similarly, this room could maybe talk to Core and ask for another service. Maybe he asks for find number of rats within 3 rooms of me or something like that. So he can ask this global entity for kind of services, things that maybe that entity has a cloud-based view, is looking down on the whole map and can kind of see these things going on. But this exists in a single central location that all of these guys can directly access. They can just say core dot this room, or core dot this from any one of these perspectives. They didn't have to create a new instance. They didn't have to have one instance ever created and just passed around to all of them. So they're all kind of holding on to a duplicate walkie-talkie or something like that. They all just have access. So that's the concept of a singleton. Now, a way you can deal with this in Unity, and I pre-did a couple of these things, is what I did is I created, let me just zoom out here, and I'll, did I call it core already? No, I just called it game object. So I'm going to rename this guy core. And what this was a empty game object. So all an empty game object is a transform. It's just somewhere on the scene. You don't see it. It does nothing can interact with it. It's just there. It lives in the scene. And because it lives in the scene, you can have scripts attached to it. So you see here, I got this empty game object that I just put in here, and I happen to attach a script to it called core. Okay. You can name the script whatever you want, but like I said, I happen to name my singletons core fairly often. So if I go in to the code here and we take a look at core, we'll come back to these things here in a few minutes, so don't worry about those. Initially, core is, let me take a lot of this stuff out just for the sake of, actually, I don't want to get stupid errors out of it. I'm going to leave them in, but we're going to ignore them for a second. So initially, core is an empty start function, an empty update function, and that's it. That's what a mono behavior is in Unity. Now, it has to be a mono behavior for us, even though we have no intention of this guy doing mono behavior stuff necessarily. But it has to be a mono behavior in order for us to attach it to a game object. If we don't attach it to a game object, when we go to add component, it won't show up as one of the scripts that's available. All right, so it needs to be a mono behavior, and it needs to have compiled successfully. So if any of you have created a script and you're like, well, why doesn't it show up? It's probably because, I mean, some of the things I've seen is if the class name is core all caps, the class name or the file name's core all caps, the class name has to be core all caps. It'll only allow you to add mono behaviors to game objects. So even if I don't have the intention of doing something every frame or doing something when it first starts up, even if I don't have that intention, if I want the guy to successfully get linked to a game object, meaning it's now in the scene, it's available to everybody else in the scene, he has to be a mono behavior. All right, so now all I did here is I threw in a public method that's also static. And we know static methods are methods that are owned by the class, and we call them using the name of the class in which they were defined. So I would say core.display. And display right now just prints woot out to the console. Doesn't do anything super special, but does something. All right. So now what we're going to look at is if I go over to player script. So this is our script that is attached to our player. We were looking at on collision enter stuff before. Now, first of all, when we look at player, nowhere in here have I created an instance of core or anything like that. Core is this entity that is floating up in the sky in our scene. And because it's attached to an empty game object, it really doesn't matter where I put it. You just throw it somewhere, you know, out of the way or whatever. Right now I just have it at 0, 0, 0. It's just sitting there. It solely exists to have this script attached to it. So nowhere in here am I creating an instance of core, but core will be accessible because he will be in the same scene. So all I did here is we were messing last time with collisions and using them. I don't know if we ever actually clicked the button trigger. Did we talk about triggers? Okay, well, we'll talk about triggers a little bit today, but I'll just give you the brief highlight. If you set a, just pick enemy here. If you set a collider to be a trigger, physics won't happen. Your guy won't bump off of it or anything like that, but collisions will still be detectable. All right, so so when I say detectable, it means that when you set it as a trigger, you are only going to be dealing with it programmatically. You don't want anything bumping around or anything like that. I mean, your guy will still hit it and kind of bounce off, but the physics won't be, you know, creating your thing flipping around and stuff like that. You know, the collision is meant to just be noticed, not acted upon or something. So we can deal with it solely programmatically. By having trigger turned off, like we have it here, now we can still deal with it programmatically like we were last time, but also the physics stuff happens where we slam into it and it starts doing things and all that jazz. So what I did is inside of on collision. So this means whenever any game object that happens to have this player script attached to it, which right now is one game object, it's my player sphere guy. Here's my player. He has this player script attached to it. So any game object that has that player script attached to it, when it collides with anything, since right now I have it inside of on collision enter, and I don't have it inside of my if statement saying, only do this stuff if you collide with an enemy. This is outside of that if statement. So whenever it collides with anybody, that's happening. Ignore the send message thing for a second. I'll explain that in a few minutes. Right now, we're just looking at this. So when the player first comes into the scene, he drops down to the ground, collision occurs. What's he going to do? He's going to scream at the singleton up in the sky and say, core, call your display method. What does core's display method do? It prints out woot to the console. You can have it do other more interesting things, and we eventually will, but this is pretty easy to test. All right. So let's just go ahead and see that happen. Don't worry about some of the other crap that's happening on the screen right now, because those are things that I'm going to talk about that I just pre-prepped for class. All right, so we already see a woot down here. And I'll go ahead and clear it. So now everything's gone, but we've had one woot. So now when I roll and hit an enemy, we get another woot because we collided with something. I get another woot. So I collided again. So every single time I collide, I'm calling upon Core's display method. All right. Now, similarly, I can go over to my enemy, and my enemy is running our box script. So if I come back in here, here's our box script, and I can do the same thing. So whenever this guy collides, so maybe I'll do it just when he collides with a player, I can say core dot display. So he has access to that same singleton. I didn't have to include anything here. I didn't have to instantiate. I just have, like, you know, this overseer that sits in our scene that I can yell at and tell them to call different methods. I can pass them values, you know, whatever I want. It's a pretty handy thing to just have this overseer kind of up there. Okay. So we'll have him do a core.display, but only when he runs into a player. So go ahead and clear this. So we should see woot one time when the player first lands. And even though our enemies have landed, don't worry about these other two things. I'll explain those in a minute. That's our send message stuff. So we have one woot, the player landed, and even though the enemies landed, the enemies only are going to call core.display when they collide with an enemy, or when they collide with a player. So now the player hit, we get another woot from that. And we got another woot from our enemy. We have 3 woots now. Original woot, and then 2 more woots from the second collision. And, you know, that can keep happening, and so on and so forth. And this guy is actually even another enemy, so we can just keep going with that. Okay, so questions about singletons. Now we can put anything in there that we want. We can have, we're going to look at maybe putting a collection up there, but for instance, just take it one step. Yeah, let's just do this. So let's create a list of game objects. All the rooms. And there's actually potentially a problem here using a list. I have to look to see if it's something called ThreadSafe, but we're just going to assume it is because that's not a topic we're going to talk about in here. I'll give you the 30-second version of it, because maybe when you've been reading something at some point, you'll see something like such and such is not thread safe, and it's usually inside of some blob that's telling you everything you want to know about some object, and you just skip by it, don't read it, because as soon as it starts sounding like jargon you don't understand, you just skip. Thread safe deals with when you have, we've already dealt with threads in here, right? So you have multiple little worker bees running. Well, what if 5 different worker bees, just to keep it somewhat extreme, all try to add something or remove something from that list at the same time, same-ish time? All of a sudden, the what's in the list and what's not in the list is very much in flux at any point in time, right? This guy might be adding something to a list that only had 1 element removed, where this guy might be adding it to a list that's had 2 elements removed and 1 more element added. So ThreadSafe effectively creates an aura of protection around the list, making sure that everybody has to get into a nice line and they only get to access the list at one time. Magically. Okay, for us, that's what ThreadSafe means. I think most of C#'s ThreadSafe stuff uses the word concurrent in it. So there's probably a concurrent list or a concurrent bag or something like that, but I'm just going to create a list of stuff. Think of this like an array list. I think technically this list is built as a linked list, unimportant for the exact moment. All right, collection of game objects is what we're going to have here. All right, so now Core owns this collection of game objects that's currently empty. So let me go back here. Do our rooms have anything on them? They don't. So what I'm going to go ahead and do is inside a project, I'm going to create a new script. And we'll call this guy the room script. All right. And whenever something that's attached to, whenever something that room script is attached to comes into existence, we'll say core dot the rooms dot add this dot game object. So anything that we attach this script to, as soon as he's born, he'll scream up at Core, add me to your list of rooms. Okay, so now Core is holding on to this giant list of rooms. He knows about everything. He doesn't necessarily know how they're organized related to each other, but this is just kind of drilling the abilities we have. We're not actually solving a specific problem. We're just kind of looking at the utility of this kind of stuff. All right, so Core is now collecting all this information. He knows about the rooms. Maybe that's handy, maybe it's not. When we start putting collisions between rooms to move a player from one room to another, maybe it's handy to ask Core, hey, I used to be in this room, now I just collided with something in this room. Can you give me that game object so I can center myself in that room or something like that? You can ask Core for all that stuff. So then Core is kind of moving you around like a chess piece. So now we can come back out here to, it probably is going to make the most sense to go to the room prefab. So here's our room prefab. I'm going to add a component to this guy. And we're going to add, there's my room script. We'll save that. Now do all our, so all of our rooms now have that room script added to it. So we added it to the prefab. So now all the things we built using the prefab have that guy on it. So now, if we just want to prove that this is happening, I'll go into my core script. Actually, just so we have an opportunity to do something here, I'm going to say public static add room game object. This guy will take it a game object go as a parameter, and we'll say core dot the rooms dot add go. Maybe we actually make that guy private so he's not accessible externally. And he's not going to actually return anything. But right after we add it, we'll go ahead and print added room. So now actually the way you're going to use Core to add a room is to call this method rather than using the list directly. So I'll just go into my room script and make a small little modification. So now we'll call the add room game object, passing it the game object for this room. That should then call that function inside of Core, which is a static function. It's public, so it's owned by the class itself. This guy will add it to its collection of rooms, and then he's also going to display to the console that a room was added. So we should now see in our console all of those individual rooms add themselves to Core. clear this. So there's our added room, bunch of added rooms up there. Hopefully we didn't have any hiccups in terms of 2 rooms getting added at once and one of the rooms ending up not being added. There are concurrent things. Actually, list might even be protected. Okay. Why that might be useful, who cares right now? It's the fact that we can have this central guy that can let us do some stuff. Go ahead. No. Possibly not, actually. Okay, there we go. Make sure it's static. It could be private. Core.the rooms is allowed to be private here. Because we're in, you can, anything that's private accessible from inside that class. So we can say core.the rooms, even though this guy is private, the rooms, make sure it's private and static. And make sure this add room go is also static. All right, let's keep rolling because I want to talk about triggers here. So what we want to be able to happen as we start making our guy move between the world is we want to be able to deal with triggers. Well, first, actually, let me talk about send message real quick to fix the problem from last class. So I created I have my player script. It was inside box script that I did this in. Where did I instantiate? Oh, he wasn't core. Okay, so let me show you what I did here. So I have core now part of, attached to this empty game object. Now, if you look at my core script up top, I have 2 public fields. And remember, when you have a public field, that exposes it to the Unity editor so you can drop values in there. So we've seen it on our player script where we had a public speed where we can change the speed over in the Unity editor. The default was 20, but I think I have mine changed to 10 right now because 20 was too fast for me. So inside of core, because core is a mono behavior, even though we're not using it so much as a mono behavior to have stuff do every heartbeat of the game, every frame of the game. But I have 2 public things, and these guys are transforms. Remember, the lowest common denominator, a game object in its emptiest form is a transform. Okay, that is a location, a rotation, and a scale. That's what a transform is. It's a collection of 3 vector 3s, X, Y, Z's. Okay, so I'm looking, what this guy wants to know about, what core wants to know about here is he wants to know about the enemy transform and a spawn point transform. And I'll show you how I'm using these guys for a simple little thing. Effectively, what I'm going to do here is core wants to be able to, in fact, I'll even rename this guy a little bit. This is my enemy prefab. So one of the things Core wants to be able to do here is he wants to be able to spawn new enemies. So you need to give him kind of the blueprint. So Core, you hand him the blueprints like, okay, I know how to build an enemy now. So now that he has that prefab, he's allowed to instantiate new enemies. And my spawn point is going to be used to dictate where I'm going to spawn that guy to make it relatively easy. I can just kind of drop it in the same place over and over again. Something like that. So out here for Core, here's my Core script. Under my prefabs, I had just taken my enemy and I drug it down here. So I have an enemy prefab. So I drug this guy. Oh, sorry. I drug my enemy prefab over here, over that enemy transform. So I've let that script know about the enemy prefab. Then my spawn point, this guy's right here, he's just an empty game object. And notice I kind of put him to the right of that enemy that's already there. Just kind of threw him in the scene. Yeah, right there. So this is my player over here. So we actually, this is my player right here. So my enemy is, one more time. Here's my spawn point is actually up here. So it'll create it here and it'll drop down to the ground. All right, so I let Core know about that spawn point as well, which is just an empty game object. It's a transform. It's a location on the screen. Okay. So then what I did here is when Core comes into existence, right off the bat, he's going to go ahead and instantiate our enemy prefab. So we have this function called instantiate. It takes a prefab as a parameter, as well as the XYZ location, the vector 3 location on the XYZ. This isn't rotation. This isn't scale. This is where in the XYZ 3D space do you want this dude to go? Now you can just hard code one in there. You can say, you know, I want it to go into a new vector 3 and then give it, you know, 2, 2, 2, something like that, you know, and then you can, you know, say vector 3 blah is equal to that guy, and then you can pass blah in here instead. Okay, but 2, 2, 2 is going to be somewhere just off the center point, somewhere in the middle of my rooms. Well, I wanted to have some sort of reasonable place to put these guys. So I gave myself a spawn point, a location where I didn't have to worry about what the XYZ was. I just said, I want it to be there. So I put an empty game object there. Then I'm utilizing his position, his XYZ position, to get whatever his vector 3 is. And if I go and move that guy around, he'll spawn at a different place and all that stuff. All right, so whenever Core first comes into existence, we'll instantiate a single enemy prefab at our spawn point. And this is our rotation, the quaternion identity. So that means don't rotate it. Leave it alone. So instantiate, can I not show you the, oh, here it is. You can actually just call instantiate from the original. I think it'll just put it at 0, 0. So there's 10 versions of instantiate. Polymorphism, right? So there's original transform parents. We actually could have just used that one. We can say true, and the quaternion is the rotation. Yeah, so we have all sorts of different versions of this guy. It doesn't matter. All we're doing is Core is creating one copy of enemy, building it from that prefab. So as soon as we hit start here, what we're going to see is we're going to see to the right of the enemy that's already there. I dropped our green color on my enemy in the scene, and the prefab is still the white color. So we'll see a a new enemy drop into the scene. Where's my guy? Oh, I don't have an enemy prefab. I must have been hitting play when yeah. One moment. All right, now I have an enemy prefab. I was just trying to create an instance of nothing. And there we go. So Core is the guy that created that instance of that dude using Instantiate off of the prefab. And since that's another enemy, he's going to play by the same rules as all of our other enemies. So he has the same scripts attached to it. So I can hit him 3 times and he'll go away, just like I could hit this guy 3 times and he goes away. So I have all of that stuff going on. All right, makes some sense? Okay, so I want to do something here real quick. Let's get a random number generator. Looks like it's basically the same as in Java. This guy. Oh, it's random. Just we just say random dot. So I can say 1 to 10. And I can print that. I want to make sure I give you everything you need for your homework. Let's use random.range instead of random range. All right, so we should get a bunch of numbers between either 1 and 10 or 1 and 9, but probably all the numbers in between. So I bet you I need to convert it to an int. Well, let me leave it as what it's going to be. I'm guessing it'll be like 1.7, 3.8, things like that. So when Core first comes into existence, it's going to spit out 10 random numbers to the console, and you're going to find those random numbers helpful for the homework assignment. Yeah, there's a 1, an 8, a 5, a 2, yada, yada, yada. Okay, so it gave us whole numbers. Okay. So for your homework, have Core instantiate 20 enemies that each take off in a random direction relative to where they were spawned. A link to GitHub and the self-assessment. So the way this should look is when the game first starts, you should see enemy drop down, go this way, enemy drop down, go this way, enemy drop down, go this way. The enemy's just going to hit and start moving in some random direction. You can figure out how you want to accomplish that random direction. I've given you hopefully some programmatic hints as to how you might accomplish that. You know how movement works because you've seen it over in our player script. There's better ways of making your guy move if you want. So if you want to look into that, you can. But feel free to, you know, set the velocity like we've kind of done. But so play around with the things that we know how to do now that we have these skills. And what I'll do is I'll go ahead Let me make sure I've saved here in Unity. Make sure I've saved all my scripts. So I'll make sure I push the most recent version of this guy. So added Singleton main, push origin. So now my cloud should have your all the code from today. Sound good? What's up? Yep. Okay, so I'll give you the link. And you could take off. I know class is over. You probably have other places to get to, but feel free to chill here. So this is my link for GitHub. So you could, if you go in here, you can clone it from here directly. Another thing you can do is you can also fork. So if you go under code here, you could say, I want to clone it. You can either download a zip file of it. You can open and get desktop, or if you can just browse, like go to my project, look at my assets, look at my scripts. You can see my core script and all those guys in there. So you can go look at my code.
Okay, and that link is basically.
I'll put it in with the assignment. Get desktop manages your local repository. The online one is the place that Get Desktop pushes it to, so that these two guys are the same. You got to get it up there. Eventually, you got to get it to the cloud. And like these guys have been messing with in their project for something else they're doing. They're collaborating on a project. So they're all sharing a global thing. So they're pulling it down. This guy makes changes. He pushes it up there. When this guy sits down to do work, he has to pull any changes. So he makes sure he has the most up-to-date local copy.
That's what I'm doing with Dick. So I'm doing data science with like Jocelyn and Lucas.
Yep.
They're on GitHub too. Slowly but surely I'm figuring it out. But that's what we're doing.
Sure. And it's good practice. I mean, just GitHub is usually one of those